All good? Cool. So I do have a tendency to speak very quickly. So please do let me know if I'm taking it a bit too far. So we will start with the introduction. In the blurb I did to kind of advertise this session, I wrote something about why would you use OpenRefine rather than maybe R or Python, if that's already what's in your pipeline, or rather than Excel, which is a great program for working with spreadsheets and data, and that a lot of people are really comfortable with and very well used to. So a lot of the things that you can do with OpenRefine, you can also do with R or Python. And if you already have a workflow that and you're comfortable with that workflow, that's perfectly fine. What I'm hoping for is that a lot of you that do things with Excel might see the appeal of especially being able to reproduce exactly what you've done and keep track of all of the steps. OpenRefine looks very similar to Excel, so I think it's not going to be a huge learning curve. Of course, there always is a bit of a learning curve when you're using new software. But also, even if you use R and Python, I use R myself, I still find OpenRefine really useful to visualize the data and the different ways in which it is messy, and that can give me ideas on what I need to do in order to clean it up and make it more usable and reusable, even if it's myself reusing this for other purposes. So many times data is very messy, and that's not necessarily a reflection on you collecting it. Maybe many times you're using public data that's been put up somewhere and is available, and people are very inconsistent in the way they fill surveys or interview data, and so many times we have to deal with answers that have differences in spelling or differences in just space, and it makes it look as if it was a different answer, etc. It's really important to know what you did to your data, what steps you took during the analysis process. In fact, a lot of journals and granting agencies are now requiring clear documentation of every single step that you took with working with your data. So that's a big appeal of OpenRefine. You can document every single step that you took and share them with your publication as supplementary material. Every single action you do in OpenRefine is very easily reversed. So we'll go through all of these things later. Everything that you do will be saved to a new file. So you're not overwriting the raw data. You're not at risk of losing the original raw data. And many times, especially if you're dealing with interview or survey data, you'll have all the surveys from March. And so you go through the whole cleaning process and you do a lot of things and you identify all of the things that can be improved with it. And then you get the data from April and you need to do the exact same thing. So OpenRefine makes it really easy to do that, to repeat the exact same steps to multiple different data sets. The strength really of OpenRefine for me is the clustering algorithms that it has. So we'll talk about this later. But if you wanted to program these yourself in R or Python, it would be really hard. I don't think I'd be able to do it. So that's one thing that I also take advantage of a lot with OpenRefine. So the nice things about it is that it's open source. In fact, it's on GitHub, and there's a growing community of people using it of all levels, from novice, expert. You can find out things about OpenRefine on Stack Overflow. It works with relatively large data sets, so up to 100,000 rows, more or less, it can manage. And you can adjust the memory allocation, especially if you're running it on a server, to accommodate larger data sets. And another really important feature is OpenRefine actually opens on your browser, but that doesn't mean that it's running from the cloud or storing your information data in the cloud anywhere. So it's only using your browser as a server to run, but everything is running in your local computer. So your data does not leave your local computer unless you very explicitly tell it to. So that's an important consideration. So it's a Java program that runs on your browser, but you don't need a web connection to run it because it doesn't interact with the internet at all, unless you want to. So you all followed the instructions to install it, and you were able to launch it. So that's great. So we'll get right into creating a new OpenRefine project and loading it. So I'm currently on a Mac, which is not my preferred operating system. I normally work with Windows, but I did it on purpose because everything that I encounter will be a learning experience, I thought. So we'll see how we go, and I might get you to pitch in for help. So I think you all have already seen how to open it, but well, maybe I might still show you. Oof, multiple me's. So to open OpenRefine, if you're in Windows, you just double click on the executable. If I'm on Mac, I've already installed it and dragged it to my application folder, so I can just open it from there. And it's opening because the little diamond is bouncing up and down. Can you see that on my slide? Oh, no, oh yeah, you can. Cool. So it's opening here in the browser. And I'll probably change my thing here. Cool. So I've already previously downloaded the data that we'll be using for this session, and hopefully you all have too. So I'm going to choose files from this computer, and I'm going to find this in, oh, I actually had it. I saved it here to the OpenRefine folder. There's my CSV file. So if you open this with Excel, you'll see it's just like any other CSV file. So I click on next here. And sorry, I should have said before, but OpenRefine can actually open a bunch of different types of files. So it doesn't have to be CSV. It can also open CSV files, Excel, JSON, XML, RDF, Google spreadsheets. And it even has, the newer version have a connection to SQL databases. I find that to be a little bit buggy. I've tried before with an SQL database and couldn't manage to get it to open. So I had to export the data into CSV and then open it from there. Just a consideration that it's a new thing, so it's not working as smoothly as it should, maybe. So you'll see here, there's a lot of information here. So one thing it does is give me kind of a preview of what this looks like. And this is exactly what it would look like if I opened this file in Excel. So there's different columns called interview date, quest number, start, end, province, district, ward, etc. Down here is information about how we're parsing the data. So it's been able to identify that this is a CSV file. And then here, there's a lot of options also. It's automatically set the character encoding to be ASCII, which is right. Columns are separated by commas, but if you see in the preview that it's not really recognizing your data well, you can play around with a little bit of these options. And this is an important one. So this is a new one, trim leading and trailing white space from strings. That's only recently been added to this, to the new version of OpenRefine, version 3.4. So that didn't used to exist. So it used to be an additional step you had to take to trim when you have, for example, province, Manica, if somebody had entered it, Manica space, it would appear as if it was a different option. But now you can just, from the outset, when you import the data, ask it to please trim all of the white spaces that are at the beginning and at the end of things so that it treats things equally. And so we're going to use all of the default settings here. Yeah, and this is where you give your project a name, and then you just create the project. So one of the most important aspects of OpenRefine is the facets. Facets means it looks at all of the possible values that are in each column, and it shows them to you very easily. So we're going to start with the village column. It groups every single value that's there. So facets are what you use. Oh, screen very fuzzy. Is that for everybody or? Yeah, I should.
Yes, it is a little bit. Yep.
What if I make it bigger? Is that better? Oh, too big. Is that any better or still very fuzzy?
It is fuzzy. I think it might be a function of your
My mm-hmm.
Yeah. But it's not too bad. I mean, I can read it. It's just a little blur. Does it bother anyone?
Because otherwise you can't read it. Okay, I'll just share my screen then in the traditional way, probably. Then. Sorry about that. Hopefully I'm back. I didn't have the permissions right. Okay, is that better? Yeah, Sophie gives me thumbs up, so potentially it's better. Okay, awesome. Okay, so where we're talking about faceting. So if I go to village, you can see every column here has a drop down arrow. And so I can go to facet, and then there are different types of facets depending on what the data is like. So I'm going to, in this case, it's the names of the villages. So I'm going to do a text facet for that. And you can see here on the left, a box appears with what looks like, I can see the first few rows have God and then Chirdozo. And so some of those options are appearing here. So that box contains every single value, unique value that's in the village column. And the number that's next to it, that gray number, represents how many times that value appears in that column. So do you notice any problems with this data? Does anybody want to say any problems that they might note with this data? One thing that I'll do is sort it by count rather than name, so you can see what the most common ones are. Feel free to unmute yourself and speak up. Yeah.
Is it like the misspelling, like they're similar words, but some are just slightly spelt differently, or there's a space or no space?
Yeah. So which one do you think is maybe this one is actually meant to be Raka? Maybe this one is actually meant to be Chirodzo. Maybe these are also meant to be Raka. And what's going on with this one? Just a misentry of a value. So rather than putting the village, for some reason, in one interview, somebody put a number in there. So we can't really do anything with that one because we don't have any context to know what the village could be. But we'll get to this later in one of the exercises. So what I was telling before, okay, there's a question, but I think we'll get them to the question and answer bit unless it's really urgent. What I was telling you before is that the power of OpenRefine is these clustering algorithms that are built into it. So you can see here there's a button called cluster. And if I click on this, it tells me no clusters were found, but there's a few methods here in the drop-down menu, and there's a few different keying functions as well that I can try to detect clusters. And so we're just going to move through some of the options here. This other keying function found one cluster. So it's grouping these two things that, as you said, Iris, there's a difference in the number of spaces in it. This one is actually finding two other clusters. This one, two other. So they're all kind of similar, but some of them find more clusters than others. So we'll stick with this one. And we're going to merge these two together. So there's this merge box here, and it asks me if I can tick them to say that I do want to merge those, that in effect, it's possible this is a misspelling of this. Of course, you need the context knowledge to know that that's the case. And then here, for the new cell value, it'll choose the more common of the two, but you can change it by clicking on the others if it's the other one that you actually want. And so after you've selected those, sorry, my screen is a bit small, but down here it's merge selected clusters or something. So I'm just going to click on that. And then with the default values, there's no other clusters that are found. So I'm going to close this after that. So that didn't solve all of my problems. It only solved some of them. But I think this Raka Namuenda is actually the same thing as Raka, or I have the context knowledge to know it. And so I want to change that so that it's grouped as the same thing. So you can also go here and edit directly here. So for these two, we're just going to edit them there, delete everything except for Raka and apply. And you'll see that that now changed the number, the counts for each of these. So it added 2 more to Raka, and then that other option disappeared. And same with this one. I think this one is most probably a misspelling of that. So I'm going to edit here. The D is in a different place. It should go there. And then I apply it. And now it grouped it with the other one. So now I have only 4 possible values for village. I can't do anything about the 49 right now. So I put in the Etherpad, I put a link to the technical details of how the different clustering algorithm work. So if you are interested in that, feel free to follow that link and learn a little bit more about that. So now we're going to talk about transforming data. And if you kind of, you can scroll around here and see that this data set has a lot of columns. So we're going to go to this column here called items owned. And you'll see for each row, for each interview, there's a list of things that the person being interviewed has said they own. So lists like this are very common when you have questions that where you can select more than one answer. Then you get kind of a list of things. But in order to analyze this, you need to be able to treat the things separately. Say, for example, if I wanted to answer the question, which item is most commonly owned by villagers in these 3 villages. So for that, I can click down on this arrow and I want to edit the cells, and I'm going to do a transformation of these cells. Now, this is where it gets a little bit trickier, and there's a little bit more to learn here. It's not as easy as point and click kind of Excel type of thing. So we need to use formulas here, but formulas are a little bit different than Excel. They use a purpose-built syntax called General Refine Expression Language, or GREL. So I also put a link in the Etherpad to learn more about this. But we're going to go through some examples, and most of the things you need to do, you can do with knowing very little about this GREL, but you can also get really sophisticated and really deep if that's what you want. So basically, I want these values to be just elements separated by semicolons. So that's what will allow me to treat them as kind of independent things that I can then look at individually. So I want to remove or replace the opening square brackets, the closing square brackets, the quotes, and the spaces. That will help me achieve what I need to do. So to do that in GREL, we write value.replace, and then we give this value replace function 2 arguments. One is the thing that we want to get rid of, in quotes, because it's a character. So I want to get rid of these opening square brackets, and I want to replace them with nothing. And so here the preview shows me where I used to have this kind of list. Now I have this kind of value. And you can see that the opening square bracket has disappeared. And so I can say, OK, on that. And then it's told me it did a text transform on 121 cells, where it replaced that opening square bracket by nothing. So now we have to do the same for all of the other things. So again, we go to edit cells, transform. And it can get a bit annoying to all of these one by one. So is there a way to combine it all into one line? Yes, there is. And the way that is done is using something called piping. And if you're familiar with R, this will be a very familiar concept to you. Basically, you take the output of this, and to that, you apply something else. And then to the output of that, you apply something else. And so we can just add on or pipe on more of these replace commands where we say everything that we want to replace. So now it's the space by nothing. And we're getting there. I just want one more thing, replace the single quotation mark by nothing. And I misspelled replace, and that's why it's telling me there's a parsing error. So let me fix that. And so now I see the preview, it looks exactly how I want it to look. So I'm also going to add that first command that I did before of the opening square bracket, and I'll tell you why in just a second. So there I've piped the 4 different things that I want to get rid of: opening square bracket, closing square bracket, spaces, and single quotation marks. On error, if any of them gives an error, I'm telling it to keep the original value then. But there, you have a few options depending on what you want. So I'll say, okay, here, and the whole items owned column has changed. So now it looks exactly how I want it to look. There's just elements separated by semicolons. So now we can use a text facet to see which items were commonly owned or rarely owned. And I'm going to close the way, once you've made a facet, you can just get rid of it by just clicking on that X, and then that facet disappears. So I'm going to go to items owned, and I do want a text facet, but I actually want a custom one because I don't want it to give me all the possible combinations of these items. I want it to be treating each item separately. So down here, there's another option called custom test facet, and this is also written in general refine expression language. And what I wanted to do is split these values by the semicolon and count each individual item. So same as before, the grel function that I'm going to be using is called split. And split takes only one argument, which is the delimiter. What is the delimiter in this case? Semicolon. And now you can see here, this is my row value, and this is what it's taking. It's taking each of these elements as an individual thing, and it's going to count each one. So doing OK on this now gives me another facet here on the left-hand side. And it, by default, it's always sorted alphabetically by name, but now I can sort it by count as well. And so we see the most commonly owned items are mobile phones and radios. The least commonly owned items are computers and cars. So you'll notice that hasn't actually changed my data. Faceting it this way using the split, that's just for visualization purposes, and it doesn't actually change the data. But this would allow me to identify if maybe, I don't know, solar torch was misspelled in one of the answers for some reason. And so I can fix it here without having to look at the whole kind of list of things, if that makes sense. While you're exploring and cleaning a data set, sometimes you do a step and you realize that actually you should have done a different step before, or actually you didn't want to do that at all. So how can I undo things? And if you see here next to the facet filter tab, there's another tab called undo/redo. And all of the changes that I've made are listed here. So I created the project first, then I changed some of the villages with the cluster method. Then I changed some other villages manually using the edit function. Then I did all these replace steps. And so going back to step 4 before doing the last one is as easy as just clicking on that 4 on that step before, and you'll see that the data set reverts to what it was before. Now, if I go out of undo redo and start doing other things, these last 2 steps will disappear. Yeah, so it'll create kind of a new history from that. Cool. I actually skipped over something else that I wanted to show you. So we did all this cleaning for the items owned column to see which items were most owned and least owned. And I'm introducing this because I'm asking in the exercises, I'm asking you to do this as well. So let's try to find the month/food column. And I know there's a lot of columns here, so it's kind of hard to find. So if I want to do exactly the same process here as I did with the other, with the items owned thing, I can go back to the edit the cells and transform. And there's a very handy history tab here next to the preview. So if I click on that, it'll show me the things that I ran before. And this is why I added the opening bracket, even though I had already removed it, because now I can click on reuse and it writes the whole expression here again. So when you're doing very similar transformations to different columns, it's very easy to recover the formulas that you used and reuse them again. So if I go back to preview, I can see that it does exactly what I wanted to do. And I click on OK, and then the transformation is done. So the last part of this session is about leading and trailing white spaces. So as I said at the beginning, when with the latest version of OpenRefine, version 3.4, but not with any of the previous ones, upon importing the data, it already gives you the option to trim the leading and trailing white spaces. And we left that checked. So we've already done that. But if you hadn't, or if due to some of these transformations that you're doing, some spaces get added, there is still functionality within OpenRefine to fix that. So I'm going to go back to the village column, and I'm going to edit one of these cells so that it doesn't say God, it says God space, and I'll apply that. So now when I do a facet on the villages, I'm going to close the item zone so it doesn't get in the way. You'll see there are two instances of God. One is God, and another one is God space, the one that I just edited. So to remove that white space, you can also, of course, here it's only one, so I can edit it there and remove the white space, or undo, go to undo and undo that latest thing that I did. But just to teach you how it would work in other cases, you can go to edit cells, common transforms, and then here there's a bunch of very common transforms where you don't have to look up the GREL for it, they're already implemented. And so one of them is trim leading and trailing white spaces. I'll click on that and you'll see that my options of villages have gone back down to 4. Okay, so sometimes you need to work on a subset of your data. And so you want to filter it to certain values before you do anything else to it. So we're going to go to the respondent roof type column. Now it'll take me a while to find it. Yeah, there. And you can see there's also a text filter option. So I can get it to filter all of the wall types that start, for example, with Mabat. And there's none. Respondent wall type? Oh, respondent roof type I wanted. Sorry. Here. So text filter, find the ones that contain Mabat. And then you'll see that the data here in the preview window changed. And I'm actually going to zoom in a little bit more so that you can see it clearer. So now it's only showing me some values of roof type that have Mabat in it. And you can decide whether you want to make it case sensitive or not, and whether you want to use a regular expression or just a literal expression. So it's telling me here, the 58, it's telling me out of the 131 total rows that I had before, 58 of them match this Mabat word in there. And then now I'm filtered, and any change I can do will apply only to that. The more common way of filtering that I tend to use more is I'll do a text facet on it so that it shows me all the possible different values. And then if you click here on one of these possible values, it'll filter to only those. And if you need two of them, for example, these two, if I hover here, there's an include button there. And so I can click there as well. And now it's showing me only those values that match these two. So for example, if I have another facet on a different column, this is already subset to only these two different types of respondent roof type. And then you can get rid of them by, again, clicking on it or clicking on this exclude button there. Yeah? So that's one way to work on subsets of your data. You can also sort the data using the drop-down menu. So of course, sort, if it's a text column, sometimes sorting doesn't necessarily make sense unless you want it in alphabetical order or something, like you have IDs or whatever and you want it to be in order. But for numeric values, maybe it makes a little bit more sense. And so we're going to try to find the column, which is altitude, and we can click down there and sort this column. And actually, I haven't told it what type of things any of the columns are. So it's treating everything as text, but I can explicitly tell it that they're actually numbers in this column, and that I wanted to start with the smallest or start with the largest, and also in what order I want it to show me valid values, errors, and blanks. So you can click and drag here to switch these things around. And so now I can have it sorted by altitude. Sorts are not permanent changes unless you tell it explicitly that you want it to be a permanent change. So as soon as I do anything else or whatever, it hasn't changed my data per se. It only changes the way it visualizes it. If you try to resort a column that you've already used, you can do chain sortings. So now if I sort a different column, I can also sort it by number. And then it all appears here. So I can remove a certain sort, reverse it, and then and then there's the making it permanent, reorder rows permanently. So that's the one that overwrites the data set and changes the order of the rows. Of course, this other data set, not your original one, the one that we're working on here inside OpenRefine. Cool. So there's a exercise about that for sorting out what happened with that town that's 49 in the exercises, and I hope we have time to do that one because I think that one's really interesting. Cool. So we'll move. We'll probably have time to do this. So I'll move to the next session, which is the section which is about examining numbers in OpenRefine. So something I showed you at the beginning but we didn't click was there was an option when importing the data to parse the columns as text, numbers, dates, etc. And we left that unclicked. And so it's treating everything as text at the moment. But clearly, some of the columns are numbers and some of the columns are dates and some of the columns are text. So you can choose to do that at the time of import, or you can kind of do it later as you go along. And then you can do different types of filters because text filters will only tell you the exact different values that are there. But sometimes you care about ranges, for example, for dates. Show me all of the interviews that happened in November, or so that's different. So we're gonna go to the years farm column, if I can find it. If anybody finds it before me.
No.
There
After village.
Yeah, good one, Emily. Thank you. Years farm. And then again, this is a common transformation. So it's listed here already. And in this case, I want to transform it to number. So there's a few things that changed. You can see the numbers moved from the left over to the right and it turned green. So green things are the things that the type has been specified rather than the default assumption that it's just text. And so now we can, for example, go here and rather than do a text facet, we can do a numeric facet, for example. And I'll close these other ones that I had from before. And so here it shows me a histogram. And then I can use these bars to filter data for which this value, this column falls into these different ranges. So that can be handy for a bunch of things. And yes, and as well, sometimes there are things that don't really match numbers. So even if you read it in as numbers, there can be something missing. For example, I don't know. This one, it might have been accidentally left out or whatever. Sorry, and you have to change it from here to text. If it already knows it's a number, it won't show. And so now if I go to facet, numeric facet, you'll see something else appeared here at the bottom. So it shows me how many of these values are actually numeric. And now it shows me that one of them is not numeric. Why? Because I made it a text and I made it a space. So this can make it really easy to identify misentries or values that are missing or things like that. Cool. So to undo that, I'll just go here to undo, redo, and go to the previous step. And now that should all be undone. So we'll do one more session about using scripts, and then we'll do another break for exercises or questions or bathroom breaks or whatever. So we've spoken a lot about how OpenRefine records what you've done and that everything is here in this undo redo tab. But how do you save what you've done as a script that you can then apply to another data set when you come up with it? There's a button here that says extract. And if I click on that, it'll give me a description of all of the steps that I've took. And on the right, it shows me, this is JSON, called JSON format. It writes code that will do that transformation using the JSON format here. Doesn't mean that you need to know and understand JSON. All it means is if I want to save all of these steps that I did, I can select all here, and I can do Control-A or Command-A if you're in a Mac, Control-C, then open a text editor, say Notepad, paste it, save it. When I come back to a new data set that I want to apply exactly the same steps to, I'll click on Apply. And I can copy and paste the whole JSON command in there as a block without having to worry about me understanding JSON or not. Yeah? Given that I'm rushing through everything else, maybe we'll take some time and do that exercise, and that'll be a nice kind of overview for Janet about the kind of things that you can do with OpenRefine. So we might do that, but if anybody else wants to share their screen and go through their thought process, I'm happy for you to. Otherwise, I will. No pressure. So we were looking, Janet, at the village, and we actually found that there were a few misspellings. So we've already fixed that using this cluster built-in functionality and changing some of the misspellings. Oh, my 49 disappeared because I already fixed it probably. Yes, okay. I had a technical emergency and had to switch computers midway. We found that there was this misentry of the number 49 within the list of villages, which is obviously not a village because there's only one survey that has that option. And so how can we find out what that's meant to be? So one of the strategies that it goes through in the material here is if we use the latitude and longitude of in which the different surveys were done, maybe we can find that 49 clusters nicely in between a bunch of other interviews that happen in a certain village. And so we can infer from that what village it might have had referred to initially. And so I'm going to remove all of the sorts that I did before. And I'll first sort on latitude as a number with the smallest first. And now I'll sort on longitude as a number with the smallest first. And so the village column is all the way here to the left. So I'm going to bring it over to the right so that I can see it together with the latitude and longitude. So if I go to edit column, I can here move the column to the end. And now it will appear all the way over there. So the village is here, the latitude is here, the longitude is here. And so now I'm trying to find that village that was 49. So it's not here. Let's see if it's in the next 10. This is only showing me 10 rows at a time. You can see that the 10 is selected there. So here it is, the 49. And it seems to fall in between a few Chirozzo entries. So that might give us some indication that it might actually be Chirozzo. But maybe that's not enough evidence to know, because they are actually quite, I don't know how this works, but it looks like the GPS coordinates are quite a bit of a mess. I don't know, I'd kind of like to plot it now using some geospatial library in R and see if they actually do form separate little clusters. But anyway, we probably want a little bit more evidence than that to kind of make the decision that that's actually meant to be Chirozzo. So another thing that we had was the interview date here. And we didn't actually do it in the session, but it was one of the exercises to change the interview date from transform it, common transformations, and change it from text to date. So I've just pre-done that already in this version of it in this other computer. And so if I move the village column back, and I can do that by going to the undo redo tab and going to the step before, and that undoes that last step that I did, which is moving the village column all the way over to the end. And the 49 was in the 10 to 20th row. I can see that the date in which that interview happened was the 16th of November of 2016. And if I sort it by interview date, I can see all of the other interviews that happened in that day. Where were they? So in this case, this is a date. I'm going to sort it by earliest first. And so I want to remove that sorting that I did before by latitude and altitude and longitude. I only want to sort by interview date. So I can click on that sort by this column alone. And so now it shows me all of these interviews done on the 16th of November of 2016. All happened in Chirozzo. Or even further, I can facet this interview date. And I can, I can select that day, the 16th of November. Of course, interview date is now no longer text, it's actually date. So I'm going to do a timeline filter instead and try to show only the ones that happen on that date. There we go. We can see now it's covering only those that happen on that date. And then I'll do a text facet on the village for only those interviews that happen on that date. And now it shows me only 49 and Chirozzo. So maybe now I do have enough evidence to say, well, the only interviews that were done in that day were in Chirozzo. So all of our interviewers were in that town. So it's pretty much very likely that this 49 is actually meant to be Chirozzo. And so as before, I can go here and directly edit this value and change it to Chirozzo. And of course, this is something that you want to explain in your methods quite comprehensively, how you arrived to this decision and why you thought you had enough evidence to infer that miss entry of 49 was actually meant to be the village Chirozzo. And so you don't have to throw away that data point because you can work it out from all the other information that you have. So now, if I get rid of that filtering by the interview date, and I only look at village, I'm down to 3 nice, well-defined villages. Would you like to keep going with other exercises, or should we keep going with the session and try and see if we can finish a little bit earlier? What do you think?
I think it's Friday and we should do what's appropriate for Friday.
I mean, it's Thursday, but
Yeah, that's true, but it's,
we can treat it as a Friday.
Yeah, there you go. I'm on Friday time already. So
that's wishful thinking there, Trent.
What's your excuse, Trent? Which time zone are you in?
I know, right? Yeah, my own.
So should we plow ahead and just keep going and try to finish? Yeah, cool. So we've covered most of the content. The last step is just how to export and save a data set from OpenRefine, right? Yeah, exporting data and other resources. Sorry, I accidentally stopped sharing my screen.
And another reminder, guys, if you have any questions, feel free to put them in the chat, and we'll make a note of it and bring them up at the end of the session.
Or on the Etherpad. I don't know. Janet, did you get the link to this Etherpad?
Yes, yeah, I did.
Yeah.
Thank you.
Cool. So yeah, this will stay live for a while after this session. So feel free to download it if you want at the end of it, or copy it and save it somewhere else or whatever. Cool. So as we said, OpenRefine kind of, as you work on a project, it saves it automatically. Every single step that you do, it gets saved automatically. So you don't have to worry about resaving it. And by saving it, I mean everything. The copy of the data with all of the changes that you've done, and also all of the steps in that undo redo tab as well. So if I close this and reopen it, it'll be exactly where I left it. And the way, when you open OpenRefine first, you can either create a new project, but you can also go to the tab here called Open Project. And here are all of the projects that you've been working on before. So you can see I've done quite a few experiments with this, playing around with this quite a bit. And by clicking on the name of the project, it'll reopen where you were. You can also export a project, which can be useful if you want to share kind of the whole steps, send the raw data and all of the steps with a collaborator, and you want them to be able to step through every single thing and make sure they agree with the way you've chosen to approach the cleaning of this data. Or even if you want to share this information as a supplement to a publication, which a lot of journals actually require now, that you share all of the steps that you took to wrangle your data. So there's an export button up here on the top right. And there's a few ways in which you can export this data. If you want the whole information, so every single step you've done to the data set and the final result, and someone else is going to open it in OpenRefine, you choose this first option, OpenRefine project archive to file. So that saves a tar.gz file. So that's a zipped file. It's another flavor of a .zip. It's a way of compressing files. And it downloads to your download directory, and then you can share it with people. If you use Mac or Linux, there's software installed to automatically extract these type of compressed files. If you use Windows, the default things won't work. You need to install software like 7-zip. So this is free software, and you can install it, download it for free if you look it up online, and that will open these tar.gz files and make it into a file that you can open directly using OpenRefine. To import an existing project, so say someone did that, downloaded it as an OpenRefine project and shared it with you, you would go to the main OpenRefine menu and import project there and choose the file, which can be, actually you don't even need to uncompress it because this can already read the compressed file directly. So cool. If you want to export just the final clean data set without necessarily exporting all of the single steps that you took in order to clean it, you can also go to that export button on the top right. And there's a few different ways in which you can export the data. So it can be as a tab separated file, value file, as a CSV file, HTML table, Excel. And again, here there's a few SQL database kind of things. Treat those with care because it's a new addition. And so just make sure that it works as you expect. But CSV works flawlessly. And yeah, you should have no issues with that. And I think that's most of it. So in the course, so this is the material that we covered from data carpentry. So you can go through and work through, especially for Janet, if you want to work through it while you watch the videos. All of the material that we covered is here. So this other thing is just gives you a few links to other online resources. I think the trickier things are using the general refine expression language to do more complex kind of operations on your data. So that I haven't really had to use that too much. I normally mostly just use the clustering algorithms in the OpenRefine to help me cluster things that should go together. But you can actually do a lot. It's really, really flexible. And yeah, you can do a lot of things. So there's some nice links here. Documentation, the wiki site. There's a book. There's an O'Reilly book. I don't know if this is the one. Let's see. No, it isn't. But there's also an O'Reilly book that I found. This one. That I'll put it on the Ethernet as well. Yeah, and so there's some other tutorials here. And please feel free to ask other people for help as well. So I'm happy for you to contact me if you have any questions with OpenRefine. I can't promise that I'll know the answer, but we can work through it together and we can look it up